All right, here we go. So, P1 notes, introduction to solving word problems for Algebra 2. All right, word problems. The thing that people really hate most about math is what we're going to start with. All right, and so it's just trying to demystify what steps you have to take in order to take words and then try to make it into an algebraic expression. All right, so we're going to break down some of these, set this up, and start seeing a pattern on how we can develop these algebraic expressions. All right, so let's start with number one. All right, the number n of days in weeks. All right, so I'm just going to start by making two categories. I got n and I got w. All right, so it's n is days and w is weeks. All right. And so if I had 1 week, I would have 7 days. If I had 2 weeks, I would have 14 days. If I had 3, I would have 21 days. All right. So what we're seeing is that for every week, I have 7 days. We just know that from common knowledge. All right. And so what I have to do in order to get that number for each of these is I really have to multiply by a constant value in all of these. All right. So when I can set something up like this, whatever numbers are constant, I'm going to be able to put that in my equation as that number. It's the numbers that are different or changing or have a variety that I would have to put in some type of variable for it. So if I was trying to solve for the number of days in a certain amount of weeks, all right, that would tell me that I have n, number of days in weeks. It would be 7 days times however many weeks I would have it. All right, so there's a couple different ways also that you could see this, and all of them are equal to each other. All right, first one is like this, or I could say n equals 7, have the dot times w. And you can also see it as maybe n equals 7, then sometimes in parentheses w, or maybe the x for times. All right, all those are sufficient ways to show this equation. And so just want to give you some variety of what you're going to actually see. All right, so let's try number 2. Similar type of situation. I have a certain amount of cents that I'm trying to find with quarters. Okay, and so I know that in 1 quarter I have 25 cents. Okay, I know that in 2 I have 50 cents. All right, 3 I have 75 cents. All right, so then what am I multiplying by in order to do this? I'll do a different color, 25 for all of these. All right, so similarly to what we just did a second ago, okay, whatever values are the same, I can put that as that value in the equation. Whatever are changing, Q is changing from 1, 2, 3, and is changing from 25, 50 to 75. I would have to put a variable in to represent those. So this would be n, number of cents, equals a 25q. I'm doing it uppercase because my lowercase q kind of looks like a 9 or a weird 8. So it's equal to the same thing. All right. Okay, let's take a look at number 3 here. See the average. What's another word for average? Mean. All right, so you can see that word. What was the mean, A, of 3 numbers, A, B, and C? So likely you are familiar with how to solve this already, right? The average is adding up all the individual values and then dividing by the number of values. So if I have 3 numbers, then I could solve this as A equals whatever those numbers are, added together, divided by A, B, C is 1, 2, 3, divided by 3. Okay. You could also see this written as A equals parentheses A plus B plus C divided by 3. Is just another way to see that same information. All right, let's take a look at 4. All right, there's some words in there we want to make sure we're really clear on. All right, product is another word for saying multiply. Okay. 2 consecutive integers, right? Consecutive means next to. Integers. Okay. These are whole numbers and their opposites, meaning negative numbers. All right, and we're going to represent the first integer as n. All right, so let's just say, all right, we got 2. So this is the first integer. Here's the second integer. So 2 consecutive. Let's do some examples first. So if I started with number 1, the next integer, next whole number would be 2. If I started with 4, the next one would be 5. All right, so if I had n, then we can see that from 1 to 2, it's just 1 more. From 4 to 5, it's just 1 more. It would simply be 1, or n plus 1. All right, so it says the product. So what I have to do now is multiply these things out. Okay, so in this case, p would just be 1 times 2, which is equal 2. Okay, this would be 4 times 5, which would equal 20. And this would be n times n plus 1 equals p. Okay, now, we can simplify this even more so by actually distributing this. I'll do a different color here. Distributing this values from there to there. Okay, so I could write this as p equals n times n is n squared plus, bring that plus sign over there, n times 1 is n. So that is my actual equation. Both those equal to each other, just one distributed out. All right, let's try 5, right? The sum, so we're adding. Okay, so the sum, so we're adding 3 consecutive integers. We talked about what those are up front, but now the middle one is n, all right? So that changes things up a little bit. So let's try this out. I got first integer, second, and third, all right? So if I started with, let's say, 2, the first one would be 1, the next one would be 3. If I started with 5, first one before would be 4, the next one after would be 6. Okay, so now, again, it said middle integer. If I start with n, okay, the value before would be n minus 1. I can see that from 5 to 4 is 1 less, from 2 to 1 is 1 less, so it would be n minus 1. And then I can see from 2 to 3 and 5 to 6, that's 1 more, so it would be n plus 1. Okay, and so again, it's the sum, so I'm just going to take all these values, n minus 1, plus n plus n plus 1. Okay, I can combine these like terms to 3 times n. And then I got minus 1 and plus 1 cancel each other out. So I end up with just 3n. All right, how are we doing? Hopefully we're starting to see a little bit of a pattern and approach. All right, let's try 6. All right, the sum s of 3 consecutive odd integers, the first integer being n. So it's odd integers now, so that changes things a little bit. Sum we see is addition. So let's do the same thing we did before, which is, all right, we got first, second, and third integers, 3 consecutive ones, first being n. So if we started with just number 1, the second would be the next odd, which is 3, and then after that would be 5. If I did 7, then be 9, and then 11. All right, so what do we see if I made this n? That the next value is just simply that value plus 2. And then the third is, if I started with n, I see it's not just plus 2, it's 2 more, so it'll be plus 4, n plus 4. I can rewrite this, the sum n plus n plus 2 plus n plus 4. Okay. Similarly, I have 3 n's, but now I got a plus 2 and a plus 4. Becomes 3n plus 6. So again, hopefully we're starting to see kind of how this goes. All right, so the sum asks of 2 consecutive even integers. So similarly, we have 2 integers. So if this was 2, that would be 4. If this was 6, that could be 8. Again, these could be any numbers. I'm just giving you some examples. All right, and then if it was n, this is just simply n plus 2. So I got n plus 2 gives me 2n plus 2. Okay. So all we're really trying to do is, the concept behind these things is to find some type of pattern, okay, or relationship, okay, among the quantities being compared in the problem that we can represent. And we can represent that pattern with an equation. Okay, so the goal is to find an equation that I can then, in any situation that's similar to this, with any starting value, I can find the answer. And so that's the goal of finding these expressions. Is then, for instance, if I went back to the front here, talk about numbers and or cents and quarters. If I had 5,280 quarters, I could just plug that into the value, multiply by 25, and I would know how many cents is. So however many quarters I have, I could still use the same equation to find the number of cents. That's what we're trying to figure out. It's helping us in the long run, but sometimes might seem difficult as we're doing it. All right, let's try example 1. Write an equation for the sum s of 4 consecutive odd integers, the first one being n. So a very similar approach we've done before. First, second, third, and now fourth integer, consecutive odd. So if I started with n, then or 1, it'd be 1, 3, 5, and 7. Okay, if I did 9, 11, 13, and 15, again, these could be any numbers, just as long as they abide by the restrictions of consecutive odd integers. All right, the first one is n, then the next would be n plus 2, n plus 4, n plus 6. Now again, remember, it's n plus 6 because I have to start with my first integer n, because that's the reference point, and then to get to that, 3 more consecutive integers or odd integers away, I got to add 2 each time, so I'm 6 away from that original n. All right, so if I add all those things together, I will end up with 4n plus 12. So I'm going to use that equation down here. I need to find exactly what those are that abide by those qualifications, but they add up to 336. All right, so, this should be equal to s. So s is 336 equals 4n plus 12. All right, so I got to get n by itself, so I do the inverse operations. All right, that will cancel out. Now this becomes 324 equals 4n. These are multiplying, so to get rid of them, I got to divide. Cancels out and leaves me with n equals 81. Now that's not the answer technically. It says find the 4 consecutive. So this is my starting point, and then my n plus 2 will give me 83. N plus 4 will give me 85. N plus 6 will give me 87. All right, so that is the answer to that problem. All right, let's try to apply it to some type of real-world situation that's at some point you may rent a car, and you're going to have an idea of how much you might have to pay for that, which is helpful. Okay. So we got a car rental company, $38 per day to rent a compact car, an additional 15 cents per mile. All right, so we got $38 per day and then 15 cents per mile. All right, so how much would it cost to rent a car for 1 day if it is driven 1 mile? Okay, so simply, if it's 1 day, okay, that's going to be 38. And then 1 mile is going to be plus 15 cents, which gives me $38.15 for 1 mile that 1 day. But now I got 3 days and 280 miles. So I got to try to put together an idea of how I'm going to do that. So I got 38 times 3 days plus 15 cents times 280 miles. If I plug that into my calculator, I get 114 plus 42, which gives me $156 for those 3 days and 280 miles. All right, so again, I can look and see the consistent numbers I'm going to put in my equation as those numbers. So I see 38, but what has changed? I went from 1 day to 3 days, so I need to put a variable in for that. So that would be n. Oops. That would be n. Okay, plus 0.15 and the number of miles. Okay, and that's going to equal c. I put parentheses around the n. Again, it could just be 38n. That's completely fine. So now I have an equation that I can use to say, all right, if I spent this amount of money, I can work back and figure out how many miles I must have driven. So this value is a value C. And so I will plug that in to get $149.25 equals 38 times 3, because it's giving me a 3-day rental. I plug that in for N, plus 0.15 M. All right, so what I'm going to end up doing, this equals 114, as we saw right above. So I'm going to subtract 114 from each side. Okay. Those will cancel out, and I will end up with $32.25 equals 0.15 M. We'll divide by 0.15 on each side. Now I'll get that I drove 235 miles. Okay. All right. So hopefully that gives you a little bit of an idea, demystifies what you have to do in order to kind of create your own equation. I know for students this can be really challenging, but hopefully you start to see some pattern and build some momentum towards that. Okay, our next notes, okay, you're just going to be talking about kind of order of operations, PEMDAS. All right, please excuse my dear Aunt Sally. And then the real number system to make sure that these words like whole numbers, natural, real, irrational, make some sense, because they're words that aren't going away and you're going to see for the rest of your Algebra 2 life. All right, guys, thanks for listening. Hope this was helpful.